Yeah, so this is my presentation about our multiple sclerosis analyzer. Now, multiple sclerosis is essentially like a brain disorder where the neurons lose their coding. And you could expect, because it's a neuron disorder, they're going to have some cognitive issues. But that's actually not the only symptom. There are a lot of symptoms to this, which is one of the things that's kind of unique to this. They're just like you could have vision problems, like you could have like muscle problems. There are just so many across the board things. And then you also have these MRI scans, magnetic resonance imaging. You have like some clinical assessments. You just have a lot of data. And like I feel like with this kind of disease, it's like you really don't know what to do by yourself because it's just so much stuff. There's also no cure for it, and like a lot of other diseases, it's best when you can catch it early. So this kind of creates a need for like an AI system because I feel the common theme with AI systems is when you need them, there's something that just takes too much computational power for humans to do themselves. So when you need a computer to do stuff really quickly for you and efficiently. So yeah, that's why we created it. And I'll talk about my project real quick, or our project. So it's two parts. One is where you import like an image of your MRI and maybe a little bit of context if you need. And then like the image kind of gets analyzed and you get like some feedback on your image. The second part is where you answer like some questions. Some of them are shown here. You can put your gender, your age, your years of schooling. You can say like if you're breastfed. There's like 15 of these, but yeah, that's the second part where you just answer questions and it will give you positive or negative for multiple sclerosis. And let me remind you another reason why this is useful. It's not some like rare disease that maybe like 2,000 people a year get. This is 2.8 million people. Like it could happen to someone you know, or maybe even multiple people you know. It has a wide scope to it. So it's not like just an arbitrary design that we're making for the fun of it. It has a use. So first, let's talk about the part where you just answer questions, and I'll talk about like how that part's coded. So this one, it's really just like it's based on a data table with like about 200 samples, and each of them have 16 features, and basically all the intelligence of that part is encoded in this thing. By the way, I got the data set from Kaggle.com. It has some nice data sets. So yeah. And then let's talk about this algorithm that kind of classifies this. So the goal of classification algorithms is they use this training data and like it kind of makes a strategy which is successful with the training data. So like it's like I don't know, it creates some strategy. Like I don't know, like if the age is over 50, do something. If X symptom is positive, then do something. It creates a strategy such that it has a high success rate with the training data. And then it hopes that when you put in other data, it's going to be correct. And then we have like a list of classification algorithms like k-nearest neighbors, logistic regression, and support vector machines. These are all cool strategies, but the one we used was random forest, which I will be explaining here. So random forest, the way it works is pretty cool. So the building blocks of a random forest are decision trees. Decision trees are quite simple, like just by themselves. They're kind of like they definitely reflect the way humans think. So like a decision tree would go like if it wanted to classify like a type of flower, it might start by asking, does it have more or less than 6 petals? And if it has less than 6 petals, it might ask for its color. But if you say yes to it's more than 6 petals, it's gonna ask like a different question that's not necessarily the same. Like how tall is its stem? 8 inches or more. And basically, it's adaptive. That's the main thing you need to know. It's like each question you respond yes or no to, it's going to give you a completely different branch. And that's why we call it a decision tree, because when you try and write it out, you'll notice you'll have to use a tree format instead of like a chronological format like how the slide uses right here. And let's talk about the context of machine learning. The way these trees are constructed in a random forest algorithm is they're built to fit the data. Basically, it creates some random tree with the important condition that if you plug certain data points in, it's going to give you the label that it has. So I don't know, say there's like a sample that says like a 16-year-old male who's breastfed as a child is positive. Then it will create a tree that when you plug in those factors about this guy, then it will input positive, and it will do that for maybe a few other data points. And let's talk about why it's a forest and not a tree algorithm. It actually creates like many trees, like say 20 or something. And like each tree is given a different amount of data that it has to adhere to. This way, the trees kind of just like cross-check each other, and they reflect different parts of the data and together form an accurate result. And when it has to predict something, the trees kind of vote basically. So if we get a new sample, each tree will run that sample through their own strategy, like their own algorithm. And say if like 14 trees say, yes, this data is positive for MS, and then 8 say, no, you don't have multiple sclerosis, then the final result is that you're positive. And I think it's cool that the trees kind of have a democracy system. Let's talk about the second part of the project, which is the generative AI. It's the part where you throw in an image and it tells you something. So we used Gemini Pro to construct this, and we feed in MRI scans. And even though Gemini it's kind of easy to use, you just throw an image in. You still got to be careful. It's a large language model, and it's trained to do all sorts of things. And that super strong strength could be a weakness if you don't know what you're doing. Because if you just throw in this image and tell me like which brush strokes would I use to paint this image, it's not going to give you a result that's accurate to like disease stuff. You have to give a very specific prompt that gives you exactly what you want. And then on top of that, you have to like embed it into the code and like make it into a nice UI that's not just like a Python system. And then speaking of like deploying it and making it useful, here are the deployment tools. The app we use to like just run the Python, it's called like VS Code, and it's compatible with everything else. It's just like a nice app, I guess. Streamlit's a pretty big one. Now there are many tools you can use to deploy it and basically make the app available for everyone else to run. But Streamlit's a nice choice for what we're doing. We care about it being convenient and not taking like weeks to implement. But what we don't care is about like having 1 million people on our site, because that's not what we're going for. We're just making a project. So this is exactly what Streamlit's for, small, convenient projects. And then GitHub basically stores it on like another server, so we don't have to use our own local processing power all the time just to keep our project running. And then like obviously there's a lot well, first of all, we'll talk about the applications. One thing this obviously accomplishes is it's personalized, because they put in their own inputs, and then we produce a reasonable result. So it does work for a decent range of patients. And it's more of like supporting what like a doctor would say. Like if a doctor says you're negative and then this says you're negative, well, that's even more reason to believe you're negative. Even if it doesn't replace a doctor's advice, it can reinforce it and kind of like give you that confirmation. And the future scope, we could definitely do with bigger data. Like our engine, like the numerical part, would be more accurate if we had like 2,000 samples instead of 200. The more data, the better, obviously. And then there's another slight issue, which is that some of the questions that you are asked for is like MRI stuff, and like the patient might not know all their MRI data like off the dome like that. And I'll probably have to consult like the clinicians. But like we're thinking of like if we have to improve on this, we could make it usable for just the patient to answer. And then like we could also do a whole nother project where we analyze like how much a certain treatment could help. Who knows? Like if you take X medicine, how much will this actually do? And it could recommend them further action. So yeah, we still have like more that we could do, and it already accomplishes quite a bit. So I think our project's pretty cool. Thank you for listening.
Yeah, the presentation is really good. I mean, it's really well structured, and let's start with a quick demonstration of the project.
Like you mean I opened the project?
Yeah.
Okay. Yeah, it's kind of floating. Hmm. Okay, I think it's ready. Yeah, so like I don't think I actually have a file. Wait, let me get one. But like I'll first explain how this works. You drop a file and then it'll give you insights. Like an LLM will give you specific insights based on like the prompt that we use inside of the code.
Okay. Let's just try to find a file, and then if it's not available, we can move ahead.
Yeah, I think my teammate might have shared me a file. You know what? I could probably just search up a file, like of an MRI scan, because it supports PNG.
Okay.
So I'm just gonna go ahead and do this. It's gonna take like 30 seconds.
Yeah, that's okay.
Hmm. Yeah, it's saving it as like the wrong type of file.
By the time it's analyzing the picture, tell me
Yeah.
about your teammates. Like, how was your experience with them?
With the what? Wait, can you say that again?
With your teammates.
Mm, yeah, I had one teammate. I don't know like if every group is just a group of two, but yeah, I had one teammate, and yeah, like basically how it works, how like our teamwork was like I knew more about the code part of it, and then she knew about the neuroscience because she's the one who suggested the project. So yeah, I guess we both kind of learn from each other.
Mhm.
And like you can see it gives like a pretty nice an analysis about this. And you can see like it's well structured and it like reflects that yeah, like it's useful that like we put in the context inside the code and like we gave it a nice prompt. Because like I'm pretty sure if you don't put in any context, it might know what's going on, but it could go a little bit off topic. It could go into like the blueness of the image, but like that's not really important here. So yeah,
Yeah.
this is pretty useful. And then let's go to the second part of the project now. So this one you just answer some questions about yourself. It does have like a weakness though, which is that you won't know all the answers to these yourselves. Like you'll have to probably contact your doctor or something like that to know like like all these symptoms. But yeah, you can just like put this and it'll like predict if you're positive or negative.
Okay. So this project